We move on to the question number 12, which is to convert between degrees and radian measures and find arc length by using central angles. There are different types of problem. Here, most important thing is finding the arc length, understanding about degrees. So we need to be thorough in the degrees, radian measures, and arc lengths and the angles. To know more about this lesson, the entire lesson, you can click on the description and look into the entire lesson. But over here, I'll be only sticking to the questions that the type of questions that will be asked. The first one here is about time to find both the degree and radian measures of the angle through which a hour hand of a clock rotates from 5 a.m. to 10 p.m. Let me just draw a clock over here, a rough image. You know there is two hands. One will be the hour hand, that is the small one, 1 hour, 2 hour, 3 hour. Now if this is the minute hand, which is a bigger one, now this can be roughly told to be 3 a.m. or p.m. Okay, and this is 6 and this is 9. Now here, okay, it is 5. They want 5 over here. Let me just change the color. 5 a.m. It's somewhere over here, right? 5. This is 5. Now the hour hand is over here, okay? And we need to see how much it will take. See the radian and degree measure from 5 a.m. to 10 p.m. It's not one time, more than one time. You'll come over here, then again you will have to go till extra till over here. That is the answer. So how would you do this? Now here basically, if you understand the concept, it's very easy. We know from 5 a.m. it has to come to 5 p.m., right? From a.m. to p.m. So 12 hours. But you know 12 hours would make one complete rotation, sorry. That is 360 degrees. That's one thing. And then you just calculate from 5 to 10 how much is the degrees. Now here another easy way is finding the how much degree is between 1 hour. See, 1 hour, 5 to 6, how much is it? Now how can you find that? We know totally there are 12 hours in the clock. We know the total degrees is how much? 360 degrees, right? So if we just start dividing, if we equate it, then we will find for 1 hour it's how much? So let us just do this. 360 degrees divided by 12 hours. So we have total degree is 360 degrees divided by 12 because there are 12 hours in 360, right? What is the answer? It's 30, right? 12 threes are 36, so it will be 30. So each hour over here, if it's 1 over here, 2, each hour would be 30 degrees. This much is 30 degrees. 30 degrees and so on. So if you add up everything, it will come up to 360 degrees. So we know each hour is 30 degrees. From 5 a.m. to 5 p.m. it is 360 degrees already. Then from 5 p.m. to 10 p.m. how much is it? From 5 p.m. to 10 p.m. how much will it be? So 10 minus 5 equals 5 hours. 5 hours multiplied by 360 degrees, that would be 150 degrees. So just add 150 to 360 because we know 5 a.m. to 5 p.m. is 360 degrees plus the remaining 5 hours, 5 p.m. to 10 p.m. that is 150 degrees. Or you can just keep on adding over here 7, 8. So it is 30, 60, 90, 120, 150. So this would be the answer. That will be 510 degrees. That will be the final answer, 510. Sorry for that. Now then, that would be the answer. Okay, let me, I just saw the answer. There's negative sign. I'll explain why is that now. So generally, how do we take the angles? Now this is the angle, this is 90 degree. We always go anti-clockwise, right? Now look at the clock. It moves clockwise, it moves like this. That means it is negative direction of movement. So the angle will be negative. Why? It indicates it is going in the clockwise direction. That is the reason. That's it. And then We have to convert this to radian, which I just forgot until I saw the answer. Over here, degrees we did. Minus 510, that's correct. How do you convert to radian? The shortcut is just divide by 180 and multiply it with pi. So we will just do it in calculator. Here, all you need to do is just divide negative 510, sorry, it's 510 by 180 degrees, 180. Now, whatever is the answer, negative 17 by 6, add a pi to it. It will be negative 7 by 6 pi. You can see the answer over here. Just whatever is the degrees, let it be anything. Just divide that by 180 degree. Now, say you have 360 degrees. It's a complete circle. How much is complete circle? 2 pi. So you will get 2 minus sign remains, but pi would be added always to convert to radians. That's it. So whenever you have degree value, say like 30 degrees, if I have to make it to radians, just divide this by 180. Whatever the answer you get, add pi over here. It will be 1 by 6 pi. So that's the answers over here. We will look into the next problem. It's about rotation. A truck with 16-inch radius wheels is driven at 77 feet per second. That is corresponding to 52.5 miles per hour. Find the measure of the angle through which a point on the outside of the wheel travels each second round to the nearest degree and nearest radian. Here, when you look at this, find the measure of angle, and they have given you how much it is driven, how much is the radius. Whenever radius comes, it is always arc length problem. Now, if you remember this formula, S is equal to R theta. Let me just explain it directly over here. This is a very, very important formula for arc length. But here, we know the arc length, how much is driven. It's told 77 feet per second. We know the radius R. What is unknown? Find the measure of angle through which a point on the outside of the wheel travels each second. That means how much is the angle, like how much is the rotation. That is what is required. Now, let me write down the formula. S, arc length, is equal to R theta. But now look here, inches, feet. You need to get both in the same unit. You can convert this to feet just by dividing by 12 and it will be decimal, or you can convert this feet into inches. It's up to you, multiplying by 12. I just now saw that it was done into inches, but it's up to you. Let's do in feet, but it depends on the option as well. See, I'll tell you why they have converted both into inches. Because if you convert this to feet radius, it will be a very small 1 point something, 1.3 feet, which will be 1.33. It might come like that. Whereas if you convert this feet, 77 feet to inches, you'll get a whole number itself. So I will consider R 16 inches, and this is the S, the distance that's traveled. It is 77 feet. So what you do is 77 multiplied by 12 gives you, it will be 770 plus 154. 770 plus 154, that is equal to 879.24, I guess. So 924 inches. This would be the answer. Let's just check quickly. It is 924, yes. So this is the inches. Instead of feet, we got in inches. Now both the units, radius and the S value, that is the arc length, is in inches. So just substitute in this given formula. Here what you do is just substitute. S is 924 equals 16 theta. So take 16 to the other side and solve. 924 divided by 16 is theta. Whatever you get, the answer, it's not in degree, it's in radian. Why? Because arc length is only given in radians. Let's use the calculator and solve. Here we put 924 divided by 16 and the answer is 57.75. That's the theta value. I'll just write it out over here. 57.75 equals theta. Now let's just go back to the question. Find the measure of angle through which the point outside the wheel travels. Okay. Yeah, this is the answer. And they are asked in radians as well. If you want the radians, just, round off to nearest radians. That's it, sorry. That is, whatever the answer you get is in radians. It's not in degree. So whenever you put in this formula, you have to convert theta to radians and then substitute. So whatever is the answer, it is 58 uh, radians is equal to theta. This is in radians. I'll write the unit over here. Radians. Now find the measure of the angle through which the point at the outside travels each second. Okay. Now whatever is happening over here is per second. Why? Each second, radians per second. In the sense, if you look over here, what is this R value? R value is 18 inches. That's fine. Radius. What is the S value we took? 77 feet or 924 inches per second. That might be going, this truck, which is a huge truck, it's going in a very high speed, it's going in very high speed. In 1 second, it covers so much inches, which is very much. See, it's 50, not high speed, like 52.5 miles per hour, which is high speed, it's like, say, 70 or 80 kilometers, I guess. So here, and 1 second itself it will take 77 feet, which is a good amount of distance. So in 1 second it will cover so much distance in the rotation. So many radians, so many times it will rotate, so many radians. The distance 77 is so much, right? The angle that is taken is so much, 58. Now what they want is over here, find the measure of angle through which the point outside the wheel each second. So this is the angle, whatever angle, each second, because we are taking the unit 77 feet per second. Basically this is inches per second. You just look at the answers. You can see over here, only rounding off the theta, we get 58 degrees. Now that's it. Okay, they have converted to degree, which is not asked over here. Oh, sorry, this is the nearest degree and nearest radian. My bad, I just saw only the radian part. How do you convert this to degrees? To convert to degrees, you have to multiply the radians by 180 degrees. But here, look at this. This is 58 radians, yes. But they have not mentioned any pi. So it's not only 180, you have to just multiply with the formula. That is 180 divided by pi. See now here, this is the conversion factor. If you have any radians, you have to convert it to 180 degree by pi. So what happens basically over here is, this is the answer, right? Just multiply it by 180 degrees, and whatever you get divided by pi value, sorry, the answer, whatever the answer is there, 10,034 degrees, right? 395 degrees divided by answer divided by pi, that is shift and this symbol over here. That is the final answer. That is 309 degrees. So I will just tell you the basic conversion. Now imagine you have got 2 pi. You have to convert this to degrees. Here you have to multiply 180 divided by pi, isn't it? So the pi cancels. Basically you're just multiplying 2 times 180, that is 360 degrees. 2 pi is a complete circle, 360 is a complete circle. That's how we do it. If you have to convert 360 degrees to radian, just inverse of this. Pi divided by 180, that will be 1 time, sorry, this is 1 time, this is 2 times, it will be 2 pi. So that's why the easy way is, if you have any degrees, say this is the amount of degrees you have, 3000, over here we have, right, 308. So all you do is divide by 180, and whatever this answer is there, you have to multiply this by pi. So multiply that answer by pi. There you go. That is the actual degree in radians. So we don't see the 2 pi. Over here it's 2 pi. We don't usually write it as 6.28. We keep it in terms of pi. Generally, most of the answers we keep in terms of pi as a unit of measure. But you can also, consider this also as the correct answer itself. Whenever you see radian, theta in radians, but no pi, that means pi has already been multiplied here. So that's the thing. That's how the conversion works, and this will be the answer in degrees. This is in radians. We go to this 68th question about planets. Earth makes one full rotation on its axis every 24 hours. How long does it take Earth to rotate through 150 degrees. Neptune makes a full rotation on its axis every 16 hours. How long does it take Neptune to rotate through 150 degrees? Now here this, right, you need to you can take as a relationship, like cross multiplication. Earth makes one full rotation on its axis every 24 hours. So if you have rotation and time, we can equate and write as a direct variation. So one rotation equals 24 hours. Divide how many rotation, how long does it take? Oh, I'm very sorry. This is not the cross multiplication. Now over here, we have to understand this concept. But now over here it is one full rotation is how many degrees? One full rotation is 360 degrees every 24 hours, right? So this degrees is equal to 24 hours time. The rotation. I had written the same correct thing, but I wrote it wrong. One rotation. That was not the correct one. Over here now, you need to know at 150 degrees how much? X. Cross multiply. Basically, you can just do it as direct variation in the sense just equate this and divide this. Take x to the other side. It will be x is equal to 150 goes to the other side and this comes down. So it'll be 150 times 24 divided by 360. This can be simplified. 12 2 times, 12 3 times, 3 1 time, 5 times 5 into 10. X will be 10. So in 10 hours, it will rotate 150 degrees. That would be the answer. It'll just take 10 hours over here. But I forgot the second part over here. The same concept is used. Let's do that now. This one, it's just 10 hours. Now, same thing. This is about Earth, right? Now we will do for Neptune. So what happens here? It takes how much time? 360 degrees. That's one rotation will be at 16 hours divided by 150 degrees at how much? X. So x goes to the other side. It will be 150 times 16 divided by 360. Now here this 0 0 cancels. 3 tables goes 5 times, 3 tables goes 12 times. Here 4 table goes 3 times and 4 table goes 4 times. It will be 20 by 3 here. The answer is 20 by 3. Or we will just do it over here. It's 6.67. You can see the answer will be 6.67 or 6.67 is 2/3, right? If it's only 0.6666 or 67 is 2/3. So it's 6.67 or 6 2/3. Now if you want to check the answer, you can just do that shift and over here 6 2/3. And what's the answer? It is 20 by 3 or 6.667. Make sure over here you are using shift and the symbol to use the mixed fraction. This is a simple relating question that's it to solve. Here we have a surveying problem. If a surveyor's wheel with a diameter of 19 inches completes 5/6 of a rotation, what is the total distance traveled in inches? Around to the nearest hundredth if necessary. Yeah, they have asked us to find the total distance. That is basically arc length, So we have to use the arc length formula. Let's write it out over here. S equals r theta. But the radius is not given. The diameter is given. So diameter is equal to 2 times the radius, or radius equals diameter by 2. That is 19 divided by 2. So here to find S, you have 19 by 2. That's the radius. What about the theta? We know it completes 5/6 rotation. 5/6 of a rotation. That means it's not full rotation. How much is a full rotation? In radians we need, not in degrees. It's 2 pi radians. So 5/6 would be 3 times 1 time. So it will be 5 by 3 pi. So 5 pi by 3. This is it. Just put this in calculator, you will get the answer. We will do it in the calculators. Here all you need is 19 divided by 2 multiplied with 5 pi by 3. The answer is 95 by 6 pi, or it is 49.74. Let's see which answer is given. Okay, both are there. So this might be given as the option. Okay, just put it in the calculator. You'll get the total distance traveled, the arc length, is 95 by 6 pi. Or if it's not in terms of pi, then it is 49.74. It depends on the given options. That's it. The next problem, 70th problem. It is convenient to know the measures of some specific angles in both degrees and radian measures. That's true. It's very important for you to know a few of the measures. Say, for example, it starts with 0, we all know. This is 0. But then, say, pi. See, 2 pi. This is ending with 2 pi or 360 degrees. Whereas pi is 180. Half of 360 is 180. Now this over here is pi by 2 and this is 3 pi by 2. So these are important things, okay? And now half of 90 is 45. So pi by 2's half will be pi by 4. So this is one more thing. And over here it will be, add pi by 4 over here. It will be 3 pi by 4. And over here it will be 5 by 4 pi. That means 1.25. And over here you can get 3 for it will be 8 by 4. Okay, my mind is going off. It'll be basically add pi by 4 over here. You will get the answer. I don't know, sometimes my brain freezes, and now it's just freezing, maybe because of the time. It's very late here. Anyways, we will read the question first and see what they're asking. It is convenient. No, yes. Copy and complete the. Okay, you have to just do all the degrees and radians. That's it. So you can easily take a calculator and do, right? So here, all you need to do is divide by 180. So 30 degrees, I know, is pi by 6. And over here, just divide by 180. You will keep on getting the answers. Pi by 6, pi by 4. Here it is pi by 3, I believe. And you can check all the others. I will tell you in calculator how to do it. All you need to do is just whichever the value, see, 30 divided by 180. That's it for degree to radian, 1 by 6. Now say, just change this 30 to 45. What's the answer? Pi by 4. Now this to 60. Pi by 3. See, over here getting 1 by 3, but remember to multiply it by pi. Since it's 1 by 3, we just write pi. 90, just check it out, okay? You will get it over here. Just change this to 90 and you will come to know it's pi by 2. Same thing with the other points. You can just easily do it and you will get the answers. You can easily write them up. So these are the answers over here. Just focus on the radians. No need of all these methods. You can directly do it. It's question number 12, MCQ. So you just choose the correct answer. So over here, all the other values are also there. You can take a look at this. And lastly, we are over here. So these are all the answers. And now, describe at least one pattern or symmetry that you notice in the completed figure. What pattern do you notice? Okay, there are plenty of patterns. Each over here, see, they are adding by 30 degrees and then you're just converting to radian. Let's just look into the answer, what they're expecting. Okay, it's an increment by 45 degree. Yes, obviously, initially when I wrote the angles, you can see over here 45 is what? Pi by 4, pi by 2. You're adding pi by 4 all the time. In the sense, I'll show in calculator. We know it's 0, add pi by 4. 0 plus pi by 4. Okay, it's 1/4 pi by 4. And then again, you're adding pi by 4. So I'll just multiply it, okay, by 2. It's half pi. Then multiplied by 3, you're going to get 3/4 pi. That's over here. Then if you multiply by 4, you will get pi. That is over here. Then here you can do 5, 6, 7. So it'll be what? Just it'll keep on 5 by 4 pi. It'll be 3/4 by pi, 7 by 4 pi, and then finally you'll come to 2 pi. So when you multiply it by over here 1, 2, 3, 4, 8, it'll be 2 pi. That's it. That's the basically you're getting the the pattern by adding pi by 4. That's the thing. It's a very simple thing. That's the answer for the previous one. Now we are going to the 71st question about clocks. Through what angle in degrees and radian does the hour hand of a clock rotate between 4 p.m. and 7 p.m.? Assuming the length of the hour hand is 6 inches, find the arc length of the circle made by the hour hand during that time. It's similar to what we had done a while ago. So I'll just draw the diagram. We know the clock, right? So basically, so this is the hour hand and minute hand. Long one is minute hand. Let me keep this as the minute hand. So this is 4 p.m. This is 3. This is 4. So this is the hour hand. Okay, 4. 5 is over here. 6 is over here. 7 is over here. So how much is it moving? 1, 2, 3. That's it. Now how much is this 1 hour? It's 30 degrees. How do you do that? 360 divided by 12. 12 is the total number of hours, right? That'll be 30 degrees. So we know each hour is 30 degrees. From 4 to 7, it is 3 hours. 3 into 30, that is 90 degrees. But what will be the sign? It'll be negative 90 degrees because it's moving in the clockwise direction. If it was like this anti-clockwise, then the angle is positive, otherwise it's negative. That's fine. Now, what do we need to do is find the arc length. S is equal to r theta. So convert this to radians. How much is 90 degrees? Negative pi by 2 radians. So over here theta is negative pi by 2. You don't need to put the value of negative. Let it be for now. I'll tell you why. And assuming the length of the hour hand is 6 inches, find the arc length. Okay. Now here one important thing to understand is the R value will be the 6 inches itself, assuming the length of the hour hand. So this, whatever is there, is R. So that is the radius because we assume that is, what is pointing. So that will be 6 multiplied by minus pi by 2. So 3 and 1, so it will be negative 3 pi. Now I'll just put this in the calculator to explain it better. Here we have 3 pi. Let me just take it over here. 3 and pi. This is the answer. But how much distance exactly is 3 pi? It's 9.424 inches. Basically, that is the distance that this particular hour hand moves. Okay. Now, why this negative sign is not required? Because it's a distance. Negative just denotes the direction. It's going in this direction, opposite direction. That's it. But doesn't matter what, the answer will be negative. The answer will be this itself. Okay, 3 pi. Negative is just the direction. So let's just check the answers. You can see here we had got negative pi by 2. Yes, that's correct. Why? Because it's going downwards. But over here they have not used negative, but even you can use negative, it will be minus, it's fine. But make sure you write the length is only 3 pi inches because it can only be positive. The distance is only positive. That's the reason. Now then we are in the 72nd problem. That is amusement parks. The carousel at an amusement park. Now carousel is basically like the turning thing. It's not like a giant wheel or something. Not a Ferris wheel, but something that moves vertically. See, for example, this is not vertically, horizontally. It's flat. Okay. Imagine you have your calculator placed on a table. Okay. Why is it not working? 1 minute. Okay, it's up and running now. So over here, imagine this is a table and you keep the calculator flat like this and you rotate it. It will turn like this, right? Same way, horizontally, something that's rotating. Here they have how much? 20 horses. Let me just take this calculator off. 20 horses spaced evenly. Its circumference, evenly in its circumference. That means everyone is distributed at even placing. The horses are numbered consecutively from 1 to 20. Okay. The carousel completes one rotation about its axis every 40 seconds. So If it starts over here, imagine this point. In 40 seconds, it'll come back to the same point. One rotation. Okay. Then what is the central angle? Okay, we have to find the angle. It's very simple. What's the total angle? 360 degrees. How many are there? 20. So what is the angle for at each point? It will be 36 is 18 degrees. That's it. So that would be the first answer. Oh, sorry, no. The central angle formed from where? From 1 till 8. 18 is yes for one placement, but we don't want advance. See, 1 2 3 4 5 6 7. 8 means there are 7 distances, right? So multiply this by 7, you will get the answer. It will be 90 plus 36, that is 126 degrees. Let's just check answers. Over here 18 degrees and multiply, so it's 126 basically. Now the next one, the part B over here, is what speed the carousel rotate in rotation per minute. So we know one rotation. See now, for example, one rotation is how much seconds over here? 40 seconds. Per minute, how many? X in 1 minute, that is 60 seconds. Okay, because over here it's in seconds, so I'm using seconds for a minute. Now just do the cross multiplication. You will get 60 by 40 equals x, that is 6 by 4, or 3 by 2 is x. That is 1.5 rotations per minute. So the rotations is 1.5. If you count for one minute, this will go past once and then it will come down over here at 6 o'clock. So that means 1.5 rotations. Here, that's the answer, 1.5 rotation per minute. And then what do we have? What is the speed of carousel in radians per minute? Now this is important. We know per minute the rotation is 1.5, right? Per minute in radians, just multiply this by 2 pi, that's it. Just multiply 1.5 by 2 pi, you will get the answer. It's 3 pi radians per minute. And now here there is one last question. A child rides the carousel for 6 minutes. Through how many radians will the child pass in the course of the carousel ride? So again, it's see the cross multiplication. Wait, yeah, 6 minutes. See now, you can do in various ways. Sorry, I thought I'll just do for this much, relating it to quantity and cross multiplying. But no, you don't need to do that. Look here. The speed of carousel is 3 pi radians per minute. Now, how much is this child riding? 6 minutes. So just multiply this. 6 times 3 pi. That's it. Because we already found per minute, right? We know for 1 minute it is so much. For 6 minutes, just multiply. You can do the equation as well. It will be the same thing. 6 times 3 pi, it's 18 pi radian in the course of the carousel ride, whichever the child opts for 6 minute ride. So that's it. It's very simple. Once you understand the main concept, all these questions will be just relatable and very easy. And we go to the last question now. It's about Ferris wheel. The London Eye is one of the world's largest Ferris wheels. The diameter of the wheel is 135 meters. Imagine, it's such a big Ferris wheel and such a huge diameter. So the radius is how much? 67.5. That's crazy. It's too big. And it makes a complete rotation in 30 minutes. So it takes 30 minutes for one complete rotation from one point to the other. A passenger gets on the ride and travels for 5 minutes before the ride stops. The passenger wants to know how far she traveled during this time. Again, it's the same concept over here, what we have just done. So please try to do it by yourselves and then we will, solve it up together. Now here there's lots of information given. So what do we need over here for the first part? Let's do part wise. During the 5-minute interval, what is the measure of the central angle of the wheel's rotation in radians? We know for 30 minutes it will complete one rotation. So let's write it out. That is 30 minutes, that's time, equals 2 pi, right? So how much will it be for 5 minutes? Divided by 5 equals x. We need to find this, right? The degree, the time interval. So we just cross multiply. X is equal to 2 pi into 5 by 30. So 5 times 2 is 10 pi by 30, that is 1 by 3 pi. This would be the answer. That's 1 by 3 pi or pi by 3, it's the same thing. Over here they have just used other relation, but the same concept and the same answer, just that I've related. For 30 minutes it's 2 pi, for 5 how much is the degrees. So that's it, you will get the answer. Next one, how to find the distance the passenger traveled to the nearest meter. Here it's arc length. Whenever you have to find distance, just use arc length. That is S is equal to r theta. We know S will be the arc length. R is what? 135 divided by 2 multiplied by theta. We just now found out was 1/3 pi. For this particular thing, for 5 minutes ride. So just do it in the calculator. You'll get the answer. Here they have written 67.5. You can directly put it in calculator. No problem at all. Say it's 167.5 into 1/3 pi. Here, try both the answers, because see, one way this is in terms of pi, 22.5 pi. But if they want in degrees, just press SD and you will get the degrees. This is 70. Sorry, not in degrees. My bad. This is in terms of pi. This is in terms of direct answer. Just that pi is 3.14. When you press SD, this will be multiplied and you will get the answer. Now this, both pi meters or the 71 meters, is the same thing. Okay, they both are same. Any one answer will be given in the options. The distance the passenger traveled is about 71 meters. So that's from the arc length formula. And lastly, explain how do you know the answer is reasonable. Now there are various methods to do that. We know this is 71 meters, right? Now first of all, how much is the total rotation? See now what they have used over here by the circumference. See, because different methods to articulate that your answer is correct. But this one over here, you can see they have used circumference. Circumference is given by 2 pi r or pi times diameter. Now this is what? Pi is 3.14 times diameter. What is the diameter? It's given away 135, right? Multiply that. How much is the total diameter? Total circumference, the outside thing, it is 423.9 meters. Now we know that the passenger just traveled 5 minutes. That is 1/6 of the entire rotation. Only 1/6, not the entire, only for 1/6 of a part. So multiply this total circumference by 1/6. How much is the answer? You get 70.65, which is what we got, right? 71. See, we also got the same thing, or very close. So yes, that is correct. The distance traveled, see over here, distance traveled by the passenger is 71 meters. And even if you do like this also, you will get 71 meters itself. That's the end of this particular question. Please do try to understand and differentiate what is exactly the radians, degrees, way to use radians. Very important thing, when it's a arc length formula, please do not use degrees, use radians. And just try practicing more problems, and then you will be very thorough with this topic.